In the previous two videos we've been looking at double slit interference. We're now going to take that a step further and look at multiple slit interference. There are a number of aspects to identify here when we look at more than two slits, but I should point out that the maths behind it is not something that you need to focus on. So we're going to have a look at a Desmos animation to show the interference patterns for 1 through to 5 slits. We'll have a look at the way that the interference pattern changes, and then we'll annotate those differences. So here you can see our interference pattern for single slit diffraction. On the vertical axis we have intensity, on the horizontal axis we have the angle from the central position. Notice that the intensity of the central maximum here is quite low. There's a reason for that that will become apparent as we continue to look at this representation. You can see here we have an indication for the number of slits that we're dealing with, and as we cycle through you'll see that the number of slits increases. Now I'm just going to let this run through the animation to begin with, just so you can get a sense of what it is that we'll be looking at as we continue, and then it's going to keep looping through, and I'm going to focus on a few different points, 6 things to focus on. Now the first thing to look at here is that for each of these interference patterns we still do have a central maximum, so each one has that bright region in the middle where it has maximum intensity. The second thing to focus on for the interference patterns is that outside of that central maximum we still have other maxima, so first order and second order, and in this case a third order as well, so those still exist. You'll notice also that the intensity of each of those maxima increases, so both the central and the first, second and third order maxima increase with the number of slits. The next thing to pay attention to is that we still have a pattern that's moderated by single slit diffraction. So this extra line that's been included here, the dashed orange line, shows the envelope for single slit diffraction. We also have a point to note about the central maxima and its width. You can see here if you look carefully that it's actually getting narrower. So the more slits there are, the narrower that central region. And finally, in between the maxima, you might notice that we start to see these small regions where they're sort of intermediate maxima is the term I'm going to use. So you can see that there are more and more of those appearing between the central maximum and the other maxima. So we're going to go through now and annotate some of those key points, and to do that we'll just leave it on this last representation. I'll also add in that single slit diffraction envelope as well. So now that we've seen all of those aspects, let's go through and annotate them on this diagram. So the first thing that we're going to deal with is this point here, and that's to do with the central maximum. And the key thing about the central maximum is that it's due to the interference from all of the slits. So at that particular point, the waves from all slits, in this case 5, are still close to being in phase. So that's the first point. The second point deals with these maxima here. So that deals with the nth order maxima, and that is basically the same point, that waves from each slit, or waves from all slits, more to the point, are in phase. So for each of those points there we have that same idea, so they're all still in phase. Now we can combine both of these 2 points and identify that what we're really dealing with there is constructive interference. The third point deals with the overall graph and one of the other changes that we saw, and that's the increase in intensity. And that basically comes down to the fact that more waves constructively interfering is going to increase the intensity of those bright regions. So by having more slits, we've effectively just got more light that can pass through, and that means that the intensity is going to increase. And the intensity is proportional to the square of the number of slits. The fourth point is the fact that we have this modulation of single slit diffraction occurring. And that's indicated by that dashed orange line. So for each of those patterns that we saw, we definitely had that same idea of single slit diffraction affecting all of the maxima. The next point was to do with the width of the central maximum, and so the key thing there is basically just that more slits leads to a narrower central maximum. The reason for that is that when you have more slits, there's more opportunity for destructive interference between pairs of slits, and so as a result the intensity drops off much more quickly when you have more slits present. The last thing to note are these features, and the reason that they occur is that waves from subsets of slits, so not necessarily all of them, will interfere, and as a result they'll produce intermediate maxima. So you'll notice that the intensity of these intermediate maxima is quite low, and that's because there's only a certain number of slits that are interacting constructively, and there'll be quite a few where there's destructive interference as well, and so we get those intermediate maxima being produced. So they're all the key points that you need to be aware of for multiple slit interference. As I mentioned earlier, there's no requirement to understand any of the maths behind how those interference patterns are produced, just that there are these differences as we increase the number of slits.